Hey everyone, today we're going to be working with the survey data from the Stat 250 Spring 2015 semester. We're going to be using that data to solve a goodness of fit test problem, and we're going to go through how to use R as a calculator to solve the goodness of fit problem by hand, and also how to use the chi-squared function as a way to solve the problem as well and come to the same result. So the first thing we're going to want to do today is open up a new script. So go ahead and click File, hover over New, and click R script. And before we get started even typing any code, let's save it to our computer so we can recall it later. So let's click Save As. And I've been working out of my Stat 250 folder and video files, and I selected this title earlier, chi-squared video script.r. It's really important to save it as a .r file so you can recall it later. So I'm going to click Save, and I'm just going to replace it because this is a script I was working on later. So let's get started. Let's upload or import the survey data. I'm just going to call it survey. I'm going to use the read.csv file.choose function. And I'm going to navigate from my documents in my Stat 250 folder where I have my CSV file saved. And so I don't have to subset my data along the way to create my vectors. I'm going to attach survey so that R will remember the file for later as we're continuing to work. Before we get started, go ahead and type names survey. And right here, that will allow us to see all of the different column names that are in the entire data set for when we're wanting to solve the problem. So for our goodness of fit test today, we're interested in seeing if there's a significant difference in the observed frequencies of vegetarians in Stat 250 and the expected frequencies of vegetarians in America. So I looked up the statistics for our population, which are vegetarians in America, and I found that 10% of adults in America identify as having a vegetarian inclined diet. So let's compare the Stat 250 data to see if there's a significant difference between those frequencies. So to do that, we're going to want to create a table of all of our vegetarians and non-vegetarians in Stat 250. So I'm going to call this veg tab as my vector, and I'm going to use the table function. And remember how we called the names survey function earlier, and you can see here one of the columns is called vegetarian. I'm going to type that in here in my table. I'm going to run that. And now if I run veg tab down here in my console, I can see there's 9 individuals that identify as vegetarian and 65 that do not. So now that we have a table generated, let's go ahead and take that same information and create a bar plot to visualize that data. We're going to use the veg table that we just generated, and we're going to add an x-axis label, and I'm going to call it "Are you vegetarian?" And we're going to need a y-axis label. I'm going to call it the number of Stat 250 students. We also need a title, and that's going to be frequency of vegetarian Stat 250 students. And finally, I'm going to use the beside equals true command because that will put my columns side by side for each other. Go ahead and highlight all of that and hit Control R. And you can see here over in the corner of my screen, we have the graph pop up. If I click zoom, you can see that there's 65 individuals that do not identify as vegetarian and 9 that do. You can close that off. So now that we've generated that bar plot, another interesting thing to look at would be the percentages, not just the frequency. So let's create a new table called veg proportions. So veg proportion tab, and all you need to do to calculate the proportions now is you can take our original table that we created just a moment ago and divide that by the sum of the table. And now if I run the code veg proportion tab, you can see that I have percentages now down here in the console. So 87.8 and roughly 12.2 is the split between vegetarian and non-vegetarian. So now that we have our proportions, let's make a bar plot to compare that with our frequency. So we're going to take our veg proportion table, and since it's decimals right now and we want it to be percentages, I'm just going to multiply it by 100, but be sure to have your parentheses in the right place so that you can have order of operations. So now we want to add an x-axis label, and we're going to call that "Are you vegetarian?" again. Our y-axis label is now, instead of the number, it's the percentage of Stat 250 students. And our title is percentage of vegetarian Stat 250 students. And finally, the last thing we want to do again is the beside equals true, so that we have our columns side by side and not stacked. Let's go ahead and highlight and Control R. And now you can see that we have, if I click zoom, we have roughly our 88% and the 12% of vegetarian Stat 250 students. Oh, one thing that would be good that I forgot to tell you to add to this graph is after beside equals true, since we're working with percentages, we want to create a limit for the y-axis. So we're going to do that by concatenating the upper and lower bounds for the y-axis to be from 0 to 100. So let's go ahead and run that. And you can see that there's like a little bit of a shift in the y-axis now where it's limiting it from 0 to 100, and it's just easier to see the difference now, and it's easier to tell that it is a percentage. So now that we've generated our tables and our box plots, we're ready to start doing the hand calculation. So to do the chi-squared goodness of fit calculation by hand, we're going to need observed and expected frequencies. So we're going to create different vectors for that. So we have our observed, and if you guys need to remember what our observed numbers were, if we type veg tab again and we run that, we can see we have 65 no's and 9 yeses for vegetarian. So we can add that to our observed. So we're going to concatenate the numbers 65 and 9. We're going to run that. And now we can create our expected frequency. And we can know that from our original problem up here where we know we have 90% of Americans say that they are not vegetarian and 10% of Americans say they do identify as vegetarian, and that's where our calculation comes in here. So we're going to concatenate the 90% times the 75 no responses in Stat 250 and the 10%, 10%. Oh, I'm sorry. Okay, just to clarify. So the 90% is of your total. So we're calculating our expected proportion. So we have 90% of our total observations, the 65 and the 9, and then 10% of our total observations. So 90% of 75 and 10% of 75. We're concatenating that for the expected vector. So finally, let's create a final vector to do this all by hand. Let's call it my chi-stat. And this is where we're using the equation from your notes, where it is the sum of observed minus expected squared divided by expected. So now if I type my chi-stat, I get a chi-squared statistic of 39 of 0.3925. Now that we have our chi-squared statistic, we need to be able to figure out the p-value that is associated with that. So we're going to go 1 minus p chi-squared of my chi-stat, comma 1. And that gives us a p-value of 0.53. So far we've generated some tables, we've generated bar plots, and we've done the hand calculation for the chi-squared goodness of fit, and now we're going to finish up with me showing you what the function is in R to perform the chi-square test using the R function chi-square test. We need to set our null P, so our null proportion. So we're going to concatenate that 90% and that 90-10% split of the population. And then we're going to run the function chisq.test of our observed vector that we created up here earlier. And then we're just going to say that the p value is equal to null p. Run that, and we get roughly the same exact results from our hand calculation. So you can see here from our hand calculation we got a chi-squared of 0.39, and with using R we got a chi-squared calculation of 0.38, and our p-value is essentially the same. We have a p-value of 0.531, and here we have a p-value of 0.535. So calculating by hand and calculating by R are very similar. It's just two different ways to come to the same conclusion. So just to review, what we covered today is we started out, we imported the survey data from the spring 2015 semester, and we created a table of our vegetarian and non-vegetarian individuals from Stat 250. We generated bar plots of the percentages and proportions of the vegetarian and non-vegetarian students in Stat 250, calculated the chi-squared goodness of fit test by hand, and used the chi-squared function, the chi-squared test function in R to calculate the same results in R.